We are doing problem 12-180. We've decided it's going to be an r theta, right? So what's the first thing that I would suggest you do now that you've decided that? Let's write down the equations, okay? So write down the equations. I'm going to do it, but don't look up here and copy. You should have this because you're going to have a cheat sheet, right? So hopefully you've got that, or at least you know where the equations are. So you write down the velocity equation and the acceleration equation, and I'll try to do the same thing. All right. Okay, so this is 180. Velocity. And this is a vector. Velocity equals, let's see, it's r dot u r plus r theta dot u theta. I got a couple of emails over the weekend. People were doing problems and they were getting the wrong answer because they were looking for magnitude and they would add the ur plus the u theta direction. You can't do that. Remember, these are vectors. If you want the magnitude of a vector, you have to take the square of one leg plus the square of the other one, square root. Remember that? But there were several that had fallen into that problem. Okay, so there's the velocity and the acceleration. I guess I should put a bar over this to be precise. They're vectors, right? The acceleration is equal to r double dot minus r theta dot squared. All that's in the UR direction, plus, let's see, 2 r dot theta dot plus r theta double dot. How many dots do you have on each of these terms? On the acceleration, you have 2, right? So that's at least one indication that maybe you got it right, okay? So this is especially important when you start taking derivatives, because sometimes you'll forget the chain rule and you'll lose a dot when you forget the chain rule. So when you just count how many dots, you go, uh-oh, I must have made a mistake, right? So watch out for that. All right, well, now what am I going to do? Okay, yeah, what I say is plug and chug, but yeah, let's write down the knowns. What do we know? Let's see, number 180. I know R equals, let's see, it's 4 sine 2 theta. All right, and I also know that it rotates constant angular velocity. Theta dot is 1.5. Okay, what are you going to do about that now? You know theta is 60 degrees, okay. Now what? How? Okay, do it. Take a derivative, see what you get. You want me to show you how to take a derivative with Mathematica? Okay, you do it by hand, okay, and then check up here and see if you're right, okay? Okay, y'all get the derivative? Okay. There's what I've got. Is that what you have? 8 cosine 2 theta, theta dot. You get that? Why is the theta dot in there? Chain rule, very good. It's the chain rule. Don't forget about the chain rule, right? Why do you have to use the chain rule here? Well, it's because r is not a function of time. It's a function of theta. So you got that extra step. If it was r equals t cubed, you don't need the chain rule. Just, it's 3t squared. Boom, done. Right? But because you don't have t in there explicitly, you have to use the chain rule. Is that clear? Now what are you going to do? What else do you need? Well, you need r double dot, don't you? You want to get that one? Or you want to plug in and chug? What do you want to do? How about we plug in some numbers here and then take a derivative? Would that work? Be careful. I'm going to plug in here and get a number for r dot. Could I do that? Do you know theta? Do you know theta dot? So you could plug in and just get a number here, right? And then I take a derivative. Is that going to work? Why not? Yeah, you have to leave it as a function until you finish all your derivatives. So you actually have to take another derivative with this as it is. Okay, so can you do it by hand? Do it. And now, did you not get this when you took a derivative? Anybody not that needs help? Anybody not get it when they took a derivative? Okay, I'll come over and I'll see you all and I'll try to help you and find out what happened. The rest of you take another derivative. Huh? You didn't bring a pen? I got a pen. Let you. Okay. Take another derivative. Why do you need another derivative? R double dot. Okay. Show me what you did. Okay, when you take the second derivative, right, you got now two things. You got the, what is it, the sine or the cosine? Cosine. You got the cosine term times a theta dot. That's going to have to be a product formula. Okay, so let me show you this, and then I'll come back here and help you in the corner. Okay, so for example, let's see, it is r dot. Mathematica says r dot is equal to 8 cosine of 2 theta, bless you, times theta dot. Right? So what I'm going to do is that's a product formula. I'm going to come in. You remember the product formula? The derivative of something times something. It's the derivative of the first term times the second term plus the first term times the derivative of the second. Remember that? If you have 5 terms, it's the derivative of the first times the other 4 plus the derivative of the second times the other 4. Plus, right? It's just the same pattern. It's just in math, I think they just teach you two terms. We'll use a lot more than 2 terms, okay? So when you take this derivative, you're going to take the derivative of this, cosine 2 theta, times theta dot, plus the derivative, or excuse me, this times the derivative of that. So try to do that by hand. I'm going to help you back here. Okay. Yeah. Let's see. What should you start off with the cosine? how to make Mathematica take a second derivative. You're going to make sure that the derivatives right. You're basically just taking two derivatives of this thing here, 4 sine 2 theta. Okay. All right, so here's how we can do it. So we're back on Mathematica, and I'm going to take r double dot. Okay, you can do it one of two ways, whichever one, and Mathematica could care less. I mean, you would if you had to do this by hand. But you can do this, r double dot, excuse me, r d dot, d dot equals, we'll take d for derivative. This is one of the few things in Mathematica that they'll take a shorthand. Yeah, everything else you have to spell it out. Solve is solve, right? Anyway, derivative is capital D. Bracket, what do you want to take the derivative of? You could do this. I say I want the derivative of r dot, and I want one of them. Okay? Or what I could do is I can say r double dot is, if you want to do both of them all at once, derivative of r dot, comma, t. So take it twice. Okay? Whichever way you want to do it, right? And you know, Mathematica has about 1 billion, I'm exaggerating, built-in functions, and I don't know what they are. Okay, I use the 10 that I always use, and I could care less about the rest of them. Now, if I ever find a job where I need one, I'm going to learn that one. Then I'll have 6 known functions, right? And that's what I recommend for you. Don't try to learn all of Mathematica; just learn what you need to know, right? Yeah.
And you already say that r dot is a derivative of itself, so where do you take that derivative?
Right, so right here, r dot is this function, right? It's this function right here. That's r dot. And that's what Mathematica thinks r dot is. And then what I do is I come in and say, okay, take the derivative of that function with respect to time. And so it does, right? And notice, where did this guy come from? Theta dot squared. How come there's a theta dot squared? Where in the heck did that come from? I mean, you did it by hand, right? Did you get a theta dot squared? No? Maybe we need to do it by hand. Okay, let's do it by hand and find out where that theta dot squared comes from. Do you think it's right? How many dots you have? This is a second derivative, right? So how many dots should you have in each term? 2, right? Let's see, here's a term, right? Everything, a term is anything that's added, right? So here's a term. How many dots you got in there? You got 1 here, but you squared. So you got a dot and a dot. There's 2. Okay? So right here, how many dots on this guy? 2. Do you have that when you did it by hand? Did you count your dots? But you only had 1? You made a mistake. Right? Let's do it by hand and see where your mistake was. But this is how you can do it with Mathematica, right? Okay, so let's do it by hand. All right, here we go. All right, second derivative, and so I'm going to write r double dot. Now this is a product, so I have 2 terms in there. I've got the sine of 2 theta, that's one of the terms, and I've got the theta dot. I'm going to put the 8, then I'll just pull the 8 out in front, right? So that's equal to 8. 8 times, what's the derivative of the cosine? Negative sine? Okay, minus sine of 2 theta. Now what? Okay, now you take the derivative of what's inside, right? Okay, times the derivative of 2 theta, that's 2. Now what? Why theta dot? It's the chain rule, right? It's the chain rule. For example, like this. Let's say, okay, here's in general chain rule. Let's say you have a function, y is equal to a function of x. Y equals x cubed, right? Y equals x cubed. And somebody tells me, you know what, I'd like you to take d dt of y. The problem is they want you to take t, the dt, of a function x, right? This is like in math. They always said, what's dy dx, right? What's dy dx? What's dy dx? And when this variable on the bottom matches the variable that's in the function, right? Then no problem. You don't need a chain rule.
So it's implicit differentiation?
Huh?
It's implicit
I don't know what they call it. I don't know what they call it, and I don't really care, but here's a math problem. Here's what you've seen in math, right? It'll be something like y equals x squared. Right? They always use x and y. I don't know why, but they do, right? At least that's when, when the dinosaurs roamed, that's when we did, right? Okay, and what I want is I want dy dx. That's what they always ask you, right? And what's the answer? 3x squared. What about the chain rule? How come they never said chain rule? How come engineers say chain rule and they don't? Well, because it's always there. And the chain rule, though, was dx dx. What's dx over dx? 1. So they just don't bother to mention it to you, right? Now, the difference is right here. They're taking the derivative, you see that, x? They're taking a derivative with respect to the variable that's already over there. Is that what we're doing? No. So what we have up here is we have theta, and we want dt of the theta. That's why all of a sudden you've got to have that chain rule. Okay, I have no idea where I'm at now. Okay, so, all right, 2. So we've got to finish this guy up. 2 times the chain rule, right? D theta dt. See that? What we're doing right here, okay, we took the derivative of the cosine as the minus sign of the stuff times the derivative of the stuff. That's 2 times, what's the derivative of theta? Theta dot, chain rule. Got it? So there's a theta dot there. Now originally there's this theta dot right there. See, it was first term times the second term. Well, here's the derivative of the first term. Now I have to multiply by the second term. See how that works? That's where the theta dot squared comes from. So this guy right here just comes right down into there. See what I'm doing? It's a product formula. Plus, okay, now we've got to finish the product formula. It's the first term times the derivative of the second term. Okay, the first term is cosine 2 theta. Bless you. What's the derivative of theta dot? Is it 0? It may be constant, but in general, would it be 0? It'll be a theta double dot. Got it? Right? So let me put that parenthesis in there so I don't forget it. Okay. So here's one term, here's the second term. So the derivative is the derivative of the first term, which is right here. That's the derivative of that term. You agree? Times the second term. Plus the first term times the derivative of the second. That's the chain rule. Or not chain rule, the product formula. Right? No? Okay. So you just have to practice it, right? Okay. So if you want to practice, get with somebody, get with a buddy, and make up stuff. Y equals tangent of theta cubed, and take the 2 derivatives of it. Okay. And how do you know the answer? Well, punch it into Mathematica, or send me an email. Right? I mean, either one. Probably quicker to learn Mathematica than to get a response from me, but either one. Okay, so you can practice those derivatives, right? Because I don't know if they're on the test or not. I did when I made it up. I just forgot. No. So make sure you can do derivatives. Does that make sense? Now what are you going to do to finish the problem off? Yeah, let's just plug and chug now, right? We know what the theta double dot, or do we know theta double dot? How? Theta dot was constant, right? Derivative of constant 0. So I know theta double dot, I know theta, I know theta dot, so I can get r double dot. I can get r dot. I can get r. I can get everything I need, right? A couple of students sent email over the weekend. They were having trouble with the mastering. they forgot to put their calculator in radians. So be careful, right? Make sure you have the right units. Any other questions about this? Can you finish it up, or do you want me to? Huh? You just have to plug it in. Yep. Because you got all the numbers now. I think the hard part was, well, maybe, you're not sure where to get started, maybe was an issue. And then the derivatives, I bet. Because if you leave off one of the chain rules, you'll get the wrong answer.
When you take R double in mathematics and you have R double dot, it's because it's D of R dot 2 times differentiated.
Yeah, right. Yeah, you got me. This is going to be the third derivative. Whoops. Yeah, so let me fix that. That would be R. Didn't I define R? No. Okay, I would do this. Let me copy and paste, so boom. You're right. Start with that. That's R. And take 2 derivatives.
Instead of negative 16, I think it gives me like negative 32 or something like that, right?
Well, let's find out what it gives me. Same thing, right?
But if you had an R dot, it would be different.
If I took a...
If you had R dot in there, it would be totally different.
Oh, yeah, because I'm doing something totally different, right? This is right. This is 2 derivatives of that function. This function is that derivative, and then I take one more. It's the same thing, right? Whether you take a derivative and then take another derivative, or you just say take 2 of them all at once. It's going to do it the same way. It's just not going to show you the intermediate step. That's all. Right? It's the same thing. When you take your second derivative, if you don't get this, then we need to see what you're doing wrong. This is the second derivative. It's the same thing as that. Those are the second derivatives. Okay? Yeah.
You have to change the 60 degrees to the grade.
You have to make sure that whenever you punch it into your calculator, you punch it in properly. Right? So this, I think it didn't it say in the. Let me read the problem. See what it says to do about the units.
I think someone had said that if we like solve through doing it in degrees, it'll be the same. You'll still get the same answer if you turn your, the black's answer into radians.
Here's what I do. When in doubt, turn it to radians. Yeah. When in doubt, put it in radians. The concern is this right here, the 2 theta. See that 2 theta? Whenever you see that, odds are that the theta is in radians, unless they tell you otherwise. So what I do is, when in doubt, convert it to radians. So I would take the 60 degrees, I convert it to radians, and then put my calculator in radians, and I just shove it through. That's what I would do. Anybody need help with taking the derivative? Make sure you got it right. If you did not get this, let me know, and the 2 of us will come around and see what you did wrong. So you made a mistake on it? Okay, go ahead. Do what?
Use TI-80.
Oh, yeah, you use anything you want except your neighbor. Okay? I mean, and now some of my colleagues will say, well, you can't use it as a, okay, fine. When you get to their class and you've been using the TI-90 or whatever the heck it is, then you got to deal with them, okay? I'm just worried about dynamics, okay? You use whatever tool you can besides cheating to learn dynamics. And I tell you, when I work, I don't, when somebody's paying me to do something, I do not put limitations on what tools I use. Right? If I need to get a big old hunker hammer, I will get a big honking hammer and smack it. I use whatever tool I have, I use. And I think that's what engineers do. Okay? So why shouldn't I test you the way you should? Right? Now, I also use Google a lot. You can't use Google on the test. So no searching the web, and if I catch you, I'm going to, I don't know how I will, but if I catch you, I'm going to do everything I can to just get rid of you. Right? but short of cheating, and I think you know what that is, you can use anything you want. And one sheet of paper, right? One sheet of paper, because here's what you're gonna do. You're going to, if I give you 20 pages of paper, you're gonna sit there and go flip through 20 pages and waste your exam time. That's what you'll do, right? I've seen it. So to avoid that, you have one sheet of paper. Just put the stuff that you really need on that one sheet of paper, and don't sit there flipping through pages, looking, hoping and praying that you'll find something. So I don't think you will. Yeah.
With the R double dot, you just factored out the 8, right?
Yes, I did, and you don't have to, but I don't know why I did. Monday, and I'm not thinking.
Could you know the problem?
Yeah, absolutely. Which one do you want to do? Everybody's okay with this? Everybody got the derivative? Don't need help with taking derivatives? Okay. Which one do you want to see?
12108.
108. Do you know what section?
Children.
It's the same section, 108?
No. It's on page 51.
No. Let's see.
The ball, or the
Oh, it's a XY thing? Okay, I know what chapter that's in then. I think it's number 7. Nope, 6. $108. There we go. All right, so let's see. Enlarge it. The man at A wishes to throw 2 darts at the target at B so that they arrive at the same time. If each dart is thrown with the speed of 10, determine the angles at which they should be thrown and the time between each throw. Note that the first dart must be thrown at theta C, then the second dart thrown at theta D. Why? Why do you have to throw the high one before you throw the low one? Yeah, they get there at the same time. So what you're telling me is you know that the lower the trajectory, the faster you got to throw it? Right? Why? Why do you have to throw it faster just to bring it down a little bit? Why? Yeah, I mean, it has nothing to do with the problem. I just want to know.
If you run at the same velocity, you want it to it's going to drop lower because of gravity.
Okay.
So it needs to go faster to reach it faster, so gravity will help it.
Yeah, I like that. Yeah, what I was thinking, in my mind, I like that. You're right. If I throw it higher, right, what's going to happen is it's going to take time for it. I can throw it slower because it's going to take time to go up and then back down again, right? So if I want to get there quicker, then what I have to do is I have to lower it down so that I shoot it a little straighter, and then I have to throw it faster because it's got to get there before it falls, which is
Also the distance increase.
the distance.
Yeah.
The distance traveled for sure. I mean, if you kind of lob it up in the air like that, it'll, it's going to go up further in the Y and then come back down further in the Y. The X is the same, right? So it's got to be going, slower, right? So that I'm confusing myself now. Okay. Yeah, that's why. I think it makes sense though, right? Okay. It's things like that I believe make you a good engineer, because what happens is somebody's going to want you to build something new. And what you'll have to do is say, well, should I make this go fast? Should I make it go slow? And you want to kind of think back and say, well, it makes sense that I would blah, blah, blah. And I need to make it go real fast. Okay, fine. Then you write down your equations, right? Because I've never had somebody go in and say, tell you what, write down some equations for me and let's see what we can do. You never do that, right? Somebody says, I want to build a new rocket. Okay, well, how are we going to build that rocket? Blah, blah, blah. Then you write the equations to see if what you're thinking is correct. Okay, so that, in my opinion, is how engineering is done. Okay, we don't do the equations to find out. You say, I believe this is going to work. Let's write the equations and prove it before I go and spend $10 million and go, oops, right? Especially if it's belongs to the mob. They don't like that too much. Okay, we're doing, yeah.
So it's saying in the problem that theta D or theta C is theta D plus theta? I can't see it.
No, it looks to me like they are saying this angle between this line and the horizontal is theta C, and then theta D is from that line to there. So they're not added. Theta C is like right here. Theta D is like that.
Yeah.
Right? They're two different angles. And they're just saying that theta D is smaller than theta C.
Actually, isn't theta C the whole thing?
That's what I'm saying. Theta C is this guy like right there. Because he was wanting to know if it was theta C was right between here. And no, it's right. You can do it between there if you want, but no, it's this angle right here. Okay, so how do you do it? Oops. I'm not sure how to get a new page, frankly. Man. You know, I hate Apple, and there's something wrong with me and apples. They just don't get along. Okay, new page. All right, so now we're going to do 108. All right, so here we go. 12, 108. All right, so what are we going to do? Well, let's rule out tangent normal. Right, you know it's not, but okay. Why is it not tangent normal?
You don't know the time.
You don't know the path, you don't know the speed, you don't know speed dot, you don't know radius of curve, you don't know any of those things. Right? So rule that one out. How come it's not r theta? Yeah, there's no origin, there's no, I mean, it's kind of the silly point, right? But on the test, you may freak out and go, oh my goodness, well, that's how you find out, right? Okay, so what is it? It's xy, right? Okay, so we're going to do xy. Can we use those fancy equations, or do we have to do something extra? You know, all those x equal x0 plus blah, blah, blah. Can we use those? How do you know?
There's only one acceleration.
Well, it's not because there's only one acceleration, but because the accelerations are constant, right? So you could, for example, have a rocket that is got gravity on it and shooting it horizontally. So you can have two accelerations, but they have to both be constant, or else you can't use those equations. Okay? Is the acceleration constant? Okay. So the acceleration is constant, so we're going to use those formulas. Do you know what they are? Do you remember them? Or do we need to write them down? You should have them written down on your little sheet, right? So you should have those. Okay, so what do we want to do? Man, I haven't a clue. So what do? You want to pick up some partial credit, right? Okay, how do you get the partial credit? What do you do? Yeah, we say, look, they tell us distance, they tell us times. I'm going to write some equations down. Okay? So let's see. I know the distance is 5 meters in the x, so I'm going to write that. Okay, so here we go. X equals x0. Aha, I have to stop and say, where do you want to put the origin? At A? Okay, so we'll put the origin at A. So what's the initial x? 0. Plus, what's the initial x velocity?
Oh, it's at an angle.
It's at an angle. And do you know the speed? Speed is 10, right? So it would be, what's the initial velocity in the x? 10 cosine theta. Is that right? Okay, so it's 10 cosine. Are we doing the C or the D? Well, you have to do them both, but which one you want? C? Okay. Theta.
Is it still going to give you 290 because it's quadratic?
I don't know. Let's find out, man. You're asking me to think ahead, right? I mean, you can do that, right? You can think it through and say, okay, I'm going to do this, and then it'll be quadratic, and then I'm going to. You can do that, which is fine.
Why is it going to be quadratic?
Huh?
Why is it going to be quadratic?
Well, there's a t squared, right? So I think there's probably going to end up being 4, but I don't know, and I don't worry about it because I'm taking a test and I just want to get points, right? But yeah, I mean you know you're thinking too far ahead. You're ahead of me. Okay, cosine theta. That's the initial speed times what? T. Okay. What's the initial time for throwing C? Right? Because you know what he's doing, right? He throws that one, he waits a little while, and then he throws the next one. 0. So we'll say that's the initial time. Okay? So t minus t0, it's t0 is 0, right? What's the acceleration in the horizontal? In the horizontal? Yeah. Okay. So, all right. So now, what else am I going to write? Just trying to fool you. Now, what else? I know the y, right? So let's do the y. Okay. What's the y? It'll be over there when he hits, right? What is the y over there? 0. That's where you chose the origin, right? So 0 equals what? What's the initial? 0. What's the initial velocity? Is it positive or negative? Okay, so up is positive? Okay, so plus 10 sine theta c times t. Okay, now what? Is it plus? Minus? Why minus? Yeah, because you want it up positive and it's accelerating that way, right? So they'd be a bless you minus 1/2. Are we in meters? Yeah. 1/2 9.81 times what? T squared. Okay, how many unknowns? C. Oh, I know x. X is 5. Okay, so that's not an unknown. Theta c and t. Right? Theta c and t? Yeah. Why did I put 0 for y?
Because the displacement is 0.
Yeah, because what I'm doing is I'm saying, you know, right here at this point, what's his position? He's 0, right? And where did he start? At 0. So the 0 on the left is because that's where he that's where he ended up, right? And where did he start? That's the other 0. Well, he's not going straight, but he's doing this. So if you put in a time, say in the middle, his y won't be 0, right? So what'll happen is if this guy right here is not 0, then you'll have to tell me the time that you want to know. Where is he? Oh, I want it at 1 second. Okay, well, he's right here. Now 2 seconds. Okay, he's right there. Now 3 seconds. Will he hit? See how that works? So the equation is good for any time, and it'll tell you where he is at that moment. And so what I'm doing is I'm saying, look, I know he hits the dartboard over there at 0. So I want to know what's the time when he hits. Does that make sense? Right? So I have 2 unknowns. Can you solve for those 2 unknowns?
One question.
Yeah.
Why did it zero out on the other side of the equation, on x?
This guy right here.
Yes, why didn't we put a plus half, and acceleration
Okay, what's the acceleration in the horizontal?
0?
1/2 times 0 times time squared. So there's nothing there. Does that make sense? Right? Because it's not accelerating. If there was wind resistance, then there'd be an acceleration, right? Because it's hitting something and he's slowing down. There'd be a deceleration. Okay. You can solve for those 2 things? Okay. So I can find the theta c, and sometimes it looks like it's quadratic. I think I'm going to end up with 2 equations, or two solutions. I'm not worried about it right now. What else? That's not going to tell me anything else, right? I need to go get theta d. How are you going to do that? Same thing? Okay, so let's just write equations for d. Is that good? All right. Okay. All right, so what's the x value for d? 5? Yeah, just like this guy here. This is going to be a 5. Let me write it down. 5 is going to go in there, right? Okay, so this is going to be for d. He's also going to hit the target. Where does he start?
Well, the exact same except for angle.
Yep, so he's going to start at the origin. What's his initial speed
10 cosine
of what?
angle d.
D. So his initial speed is 10 cosine. Whoops. Times what?
T2 minus T1.
What's T2?
And,
But what do you mean by T2? Why are you going to call it 2?
it's
T2,
gonna be, because you throw it after,
right?
so you need to know the time between the
Okay. All right. I agree with you. Here's what I'm thinking. You know, I've got T that tells me when it hit, the first one hit. isn't the second guy supposed to hit at that same time? Okay, so what I'm going to write is t, the same time, t minus what? T naught, right? So I throw the first one, pow, I threw him at time equals 0. That's the start of the clock. Then I wait 2 seconds or whatever, and then I throw B, right? And then they hit at maybe 10 seconds. So I throw the first one, right? 10 seconds later, pow, right? And then I throw the second one after 2 seconds or 3 or whatever it is I'm going to solve for. And he hits in 10 seconds. So what I'm going to do is I'm going to say, well, this would be t, the same t is above, minus the initial time. When did I start throwing him? T0. Right? So what you're thinking is I would call it in 2 different times. That's fine. Yeah, you just have to keep it straight. You're on the right track. You just got to keep it straight. To me, this seems to be clearer thinking. I mean, my brain's not that good, right? I'm just thinking, hey, what this says is they're going to hit at the same t, but D, the second one, was weighted until t0 before I let it go. Do I need any plus 1/2 AT or anything like that in here? Okay, because there's no acceleration there, right? Okay, what else do I know about that guy? Yeah, you know the y, right? So let's write down the y. Okay, where does he hit in the y direction? At 0? Okay, 0 equals. Where does he start? At 0? Plus, what's his initial velocity? 10 sine theta d. Very good. Times what? Yep, t, the same time when they hit, minus the initial time that I held him back. What else? Minus 1/2. A is 9.81. T minus T0 squared. How many unknowns? Theta C, T, theta D, T0. How many equations? 4. Can you solve it? By hand? Okay. You can do it either way. I like to let every Mathematica do it all, right? But if you had to, how would you attack it if you had to do this by hand? Yeah, solve the first 2 equations and solve for t and theta c. And it's been a long time since I've had trig and trying to solve those guys. I think you solve for cosine equals and sine equals, right? And then you tangent equal, and then I don't know. Here's what I do in my old age. Go to Mathematica. I say quit, because I want to forget everything I've done so far. And then I'm going to type in equations. Bracket. Okay, it's going to be 5 equals 10 cosine of, I'll just call it THC, theta C, times time. That's one equation. So far, so good? Here's another one. 0 equals 10 sine THC times time minus 1/2 9.81 times t squared. Is that good? And third equation, 5 equals 10 cos THD times t minus T0. And then last one would be 0 equals 10 sine THD t minus T0 minus 1/2 9.81 t minus T0 squared. And that's it. So I'll go bang. Look about right. I don't spend a whole lot of time staring at them, but then solve. What do you want to solve? Equations for what? How many equations you have? You have to list 4 things. You have to tell it, I want you to solve for these 4 things. Okay, I want T, whoops, put it in a little wiggle bracket set of stuff. T, T0, THC, and THD. Let's see what it does to me. Hey, not bad. Heck of a lot easier than doing it by hand. I'm gonna zoom it out. Let's see. Shrink this thing down. Holy cow. Somebody said there were two answers? I don't think, bless you, I don't think so. Which one are you gonna pick? Well, if you look at this one, these are all negative times, right? Negative time, negative, negative, negative. Okay, here we go. Here's a positive time. Negative, negative, negative. Here's a positive time. Yeah, here's a positive but a negative. That one's not getting good. This one, oh yeah, this one says it's the same, right? T0 is 0 and the 2 angles are the same. Well, that's kind of dumb, right? But it would work, right? You threw both of them in the same path, same angle, they would get there at the same time, wouldn't it? Okay. Let's see, so I don't want that one. Here's one down here. This one looks pretty good. Right, so here in the T0 is 1. Well, that doesn't make any sense because they've already hit, right? Right, because the T0 should be less than T. Okay, so that one's probably not right. Here's a good one. That one looks, I think that's the answer right there, right? Because all the others, this, you know, how can T0 be bigger than this one? He arrives before I threw him? I don't think so. So I think that's the answer right there. And what about these angles? Are they going to be in degrees or radians? Why? Mathematica always does radians. I don't think you can, it's not like your calculator where you just push a button and it'll do degrees. I don't think there is one. It just automatically does everything in radians.
Could you go to where you put the salt part?
Uh-huh. You want me to show you what could go wrong?
Yeah.
Okay. People are copying this. I'm going to post it, so you don't have to worry too much about it, okay? But I'm just going to copy and paste. So I'll copy this guy. And we'll come in down here. Okay, so here's some of the common mistakes. You'll, instead of having equal, equal, you'll put 1 equal sign. It's hard to tell, right? It's hard to tell. And then I'm going to copy this solve. And we'll see what happens when you do something like that. You know, this is why I think if you plan to use Mathematica on an exam, you should practice it because you'll make these silly mistakes and you want to see what it looks like when you do. So, right, see, so I messed up. There's a single equal sign right there. So I'm going to go like that. And what is it saying? Cannot assign to raw object 5. I've never in my life seen anything like that. Have you? Because you use a single equal sign, right? Because basically what it's saying is, look, you're trying to tell me to take this, and instead of calling 5, 5, you want me to call it this thing? Are you kidding me? Right? It says, I can't do that. Right? But I mean, it doesn't say, hey, you big dummy, you left a single parentheses. It doesn't tell you that, all right? If it was smart, it would tell you that. It'd say, hey, man, come on, double equal, right? If it was really smart, it'd put it in there for you, right? But what it does is it says, I can't do this. And so you'll see that, and you'll freak out and go, oh my gosh, you know, Mathematica just crashed. I found a bug in no, you didn't find a bug in Mathematica, right? Right? So things like that will happen. So, you know, what do you do? Well, if you're on an exam and something like that happens and you start to freak out, you raise your hand, I'll come around, and hopefully I'll be able to spot it and say, oh yeah, right there. Now, if it's a Mathematica problem, I will be happy to help you. If it's a dynamics problem because you got the wrong equation, I'm going to say, hey, you're on your own. And that is clue to me. It ain't Mathematica, it's dynamics. Okay? So if you try Mathematica and you freak out, raise your hand, I'll be happy to try to help you. Okay? Doesn't mean I'll be able to find it. It just means I will try to find it. Okay, somebody had a question? Yeah.
Where did you put 0 on the theta d, the equation, the second equation?
Why do I need a T0 here? Right? Can somebody help him? Why do I need this T minus T0 here?
Just throw it out.
Because it was the first one
because I threw it at a later time, right? Because
So
time.
wouldn't the first one be T0 then?
Okay. Why is there not a T0 there?
It's minus 0.
Yeah, because when you got a stopwatch, right? And I've got 2 darts, and you say go, and I throw it as soon as you say go. That was time 0. And then I'm going to wait for this number of seconds, and then I'm going to throw the next one. I'm going to throw him faster, lower angle, after a little delay. So I'm going to throw the first one at time equals 0, boom, and it hits. Actually, he's in midair, and then I'm going to throw the next one, and they're going to get there at the same time. That was what the problem said. And this is the initial time that you threw it. Your book doesn't include that, right? Your book doesn't include the T0s. So you have to kind of, if you use strictly the book, you got to, right? But that's what the T0 is. It's a, when did you start it? This guy was started as soon as you said go. This guy was started sometime after that.
So,
Yeah, I don't know what else to tell you. Okay, what else you want to do?
133.
12.133? Okay. Do you know what section it's in? Normal tangent, thanks, that helps.
So the answer, do we have to put the angle in radians or degrees like
Here's the deal. If you, when I grade, I base things on kind of what the class is doing. So for example, if you're the only person who put your answer in radians, everybody else is putting it in degrees, then, and you don't tell me it's radians, then you may lose a couple points. Not very many, because everybody else knew how to, it should have been feet or whatever, and you didn't, so you should lose a little bit. If everybody is just all over the place and missing, then I usually don't worry about the units. Right? I mean, if you're making serious dynamics mistakes, I don't worry so much about the fact that you didn't get the unit right. But if everybody's making 100 and 95 and 100 and 100 and you get the units wrong, well then why didn't you get the units? He got them. See what I mean? So I don't know how to, other than that, I don't know what to tell you.
Can we do a problem
He asked me for 113?
133.
133. And as soon as I do that, then I'll help you.
I was able to solve it by hand, but not
Okay. Yeah. I don't know what time it is, but, if I have time, unless you want me to do his. Okay. Let me do that one, and then I'll come back to yours. I have a doctor appointment after class. I won't be in office hours. As soon as the doctor's over, I will rush back, and then I'll be here all after from then until, quitting time. So I won't be there at 9 o'clock. I didn't hear you?
So you'd be leaving around like 4 in the evening?
No, about 5 o'clock. Yeah. Let's see. Tangent normal is in 7, I think. So here we go, and it's 133. Uh-huh. Okay, let me enlarge it a little bit. Come on. you dog. Okay, let's see. Okay, 133. Car B turns such that its speed is increased by AT. And it gives me a formula where T is in seconds. If the car starts from rest when theta equals 0 degrees, determine the magnitudes of its velocity and acceleration when T equals 2 seconds. Okay, so is this a tangent normal? Is it a R theta? Is it an XY? What is it? And how do you know? Yeah. They, beg your pardon? Well, I thought I could, but I'm not sure I know how anymore. Is that better? Okay. Okay, so it's tangent normal because what they're giving me is they're saying AT. AT equals boom, boom, boom. And They say magnitude of velocity and acceleration. Well, that doesn't help because you could use r theta for that as well. But I know the path, right? The path is circled. It's a circular path, and they're telling me the AT. What is AT? How does that relate to the velocity? Isn't it the tangent component of acceleration? Okay, so they're telling me the tangent component of acceleration, v dot. That's v dot. Okay. All right, and so they want to know what is the magnitude of velocity and acceleration when t equals 2 seconds. Okay, how would I start? How would I recommend you start? Okay, let's write some equations down, right? So let's see. Come on. Come on. Okay. New page. This is 12.133. Doesn't like it when I touch it with 2 fingers. Okay. 12.133. Okay, so give me the equation for speed or velocity in tangent normal. Velocity equals speed in the tangent direction. What's the normal component of velocity in tangent normal? What's the normal component of velocity? 0. Why? Because velocity is always tangent to the path, always. Right? There is no normal velocity, only tangent velocity. Okay, they want me to find the velocity, right? Or the magnitude of velocity. All I need is the speed. How am I going to find the speed? Integrate. Yeah, they told me that the v dot, right? They said the acceleration in the tangent direction. That's v dot. Let me write that down, so just so we remember. The acceleration is equal to v dot in the tangent direction plus what? Do you remember? V squared over radius of curvature in the normal direction. Does it always point in or out? In. Always points in. Okay. So basically they said that the AT is equal to this function. So I've got, all right, V dot. V dot equals, and what is it? It's 0.5 e to the t.
It's the same function, right?
Yeah, it's the same one, right? 0.5 e to the t. That's v dot. I don't want v dot, I want v. That's a differential equation, right? How do we solve differential equations? Separate the variables, okay? So we're going to separate the variables. So this is dv dt equals 0.5 e to the t, right? So I'm going to multiply through by the dt. I'm going to have dv equals 0.5 e to the t dt. Can you integrate that?
Yes.
Can Mathematica integrate that? Yeah. If you can do it, it can do it. Okay. So what's the integral of that? I believe it is 0.5 e to the t plus what?
C.
Plus a constant. How do you find those constants? Always the same way. You got to tell me a time when you knew the speed. Okay, so I'll look back on the problem and I say, okay, speed is increased, blah, blah, blah. The car starts from rest. V equals 0. Starts, time equals 0. So when time equals 0, speed is 0, right? Okay, I'm going to plug that in. Speed is 0 when time equals 0. What's e to the 0? 1. So 1 times 0.5 is 0.5 plus c. So what's c? Okay. So the speed is 0.5 e to the t minus 0.5. Can you find the magnitude of the speed? Magnitude of the velocity? Yep. Because they wanted at time equal 2. Put in a 2 for time. Boom, you got it. Does that make sense? Yeah? Now, why would you ever want that? Who knows? They're just trying to make sure you can take derivatives and integrals. I mean, that's really all it is. I mean, nobody cares. It's just a problem. Okay, so what else did they want? They wanted acceleration. Do you know everything you need to know for acceleration? What do you need? You need v dot? Do you know it? It's given, right? So you just plug in the time, boom, you got the v dot. What about v squared over rho? You got the v. Do you know the rho?
Yes.
5 meters. Okay. How would you find the magnitude of that? You're going to get two numbers. Square both, add them, square root. Some of you were just adding them. You don't just add them. They're vectors. So you got to take this guy plus squared plus the other guy squared, square root. Okay? Good?
You know, looking at formulas, I would get misled, because, you know, there's like the magnitude and squared. I don't know, I feel like something like the formula, because it says plus, and like, so you just add it. So I just like sometimes I've added before,
Oh.
I get the answer wrong.
Oh.
Yeah.
So sometimes, I don't know why it's fooling you. What's causing you to?
Just looking at the formula, since it says plus, you know, you have your e dot. and
Oh, right.
You can look
Yeah.
at the bar and then it's magnitude of it.
Yeah, that's why I try to put a little bar over it to say this is a vector. It's not just a number plus a number. It's a number in a direction plus a number in a direction. That's not the best I can do for you. Okay. Yeah, because they're two different directions. Yeah, got to keep that straight. Just like x and y, it's just tangent, normal, or weird, but they're just two different directions. Okay, and you had a question. Somebody over here. You had a question, didn't you? 170. Do you know what section it is? Probably 12.8, right? Okay. $12.8. Okay, so you just want to see it with Mathematica. Particle is moving along a circular path having a radius of 6 such that its position as a function of time is given by theta equals sine of 3t, where theta is the argument for the sine radians and t in seconds. Determine the acceleration of the particle when theta equals 30 degrees. Starts from rest at theta equals 0. Okay, so to me, is this a tangent normal or r theta? What is it? Yeah, I think it's r theta because they say circular path. You give me the radius. So what's r dot? 0. Very good because it's a circle. It's always going to be 6. What's r double dot? 0. So I know r dot, r double dot. They give me theta as a function of time, so I can get theta dot and theta double dot, right? Okay. And his question was really about Mathematica. So let me just open up Mathematica. Oops. And we'll just try to do it all in Mathematica. Okay, so here we go. We'll say quit. Let's say this is problem 12-170, just so you can mark it when I post this. Okay, so what I know that theta equals sine of 3t. And theta dot, come on, baby. Yes, I'm saying th is sine 3t. And I don't know why it's gagging on me.
Oh, you forgot the semicolon.
I forgot the what?
Semicolon.
I don't need one. The semicolon, by the way, means just don't print it. You know, it's here, but don't print it in the output. I don't know what I've done wrong. Let me try to save it before it crashes. No, because I want to say that th is this. So before it crashes, let me save it. Okay, we'll try it again. There we go. This is a crappy computer, by the way. There we go. Come on. Okay, good. See, I used 1 equal so that if I were to say, what's TH, it'll tell me it's sine of 3t, if it ever comes back. It's probably doing a virus check or something stupid. There you, what? Well, I don't know what's not cooperating. There we go. Okay, I don't know what's going on. Okay, so there's my theta, and I want theta dot, right? And what is that? That's a derivative of this guy, so it'll be a derivative of theta with respect to time, right? So that's theta dot. How about theta double dot? Okay, so I'll take the derivative of theta twice. Which is kind of silly. I mean, you wouldn't start over, but, you know, mathematically it doesn't care. It's real fast. So there's your 2 derivatives. Right? So now you want acceleration, I think? Okay, so what's the acceleration? You remember the formula? Let me say R is, what was R? 6? R dot was 0, and R double dot is 0. There we go. Okay, so acceleration in the R direction is, you remember the formula? R double dot minus R theta dot squared, right? So that's the radial component. The A theta, the theta component. Remember what that was? 2R dot theta dot plus R theta double dot. Okay. Do I know the time?
No,
Ah, okay, I know theta. Theta is 30 degrees. Okay, so I'm going to go like this. I'm going to say, all right, solve 30 degree equals sine of 3t. What do you want to solve for? T? Okay, what in the world? Whoops. Yeah, hair silvers. Oh, that's somebody else's hair silver. There's no password on it, right? So anybody can. I just hope they don't pull up something really nasty. Anyway. Yeah, right? I mean, it could be embarrassing. And it's being recorded, too. So anyway, so what is this conditional expression garbage? What is this? Look at this. What in the world? What? You see what they're...
yeah.
Okay, Mathematica says, look, I don't know that you only want one angle, right? You know, if you think about it, 30 degrees equals 3 sine t. Aren't there a million answers? Okay, it's going to give you every single one of them. And how does it do it? It says, okay, here's the answer, right? Here's the answer, plus 2 pi times a number. See, this is any integer. 2 pi times 0, 2 pi times 1, 2 pi times 2. Get that? See, so what it's telling you is this is the answer, inverse sine of 30, plus 360, plus 360, plus 360, plus 360, right? So it looks horrible, but what's the real answer that you're looking for?
Okay.
Yeah, so what I'm going to do is I'm going to copy and paste this guy right there. So here's one of them, right? There's 2 possible answers. There's that one. And, whoops, I forgot the parenthesis. Right, and I'd like to see it as a number. Thank you. So it's either that, and that's going to be in radians, or excuse me, this is time, so it'll be seconds, or it's this one. Show it as a number. Right? So it's one of those 2 times. Which one would you pick? Why the second one? There's going to be 2 times when it hits 30 degrees. I would take the first one, yeah. Now, Look, you're trying to solve sine of theta equals 30 degrees. Would you really use Mathematica for that? No. Get your calculator out, take the inverse sine of 30 and get the time. Right? That's the way I would do it. You don't want to use it unless it's helpful. So, yeah, it looks like some of you are struggling with derivatives. Whip out Mathematica. Let it do it. Okay? Let it do it. But taking the inverse sine? Come on. Get your calculator out and just do it. Instead of having to deal with all this garbage. Right? But it could do it. Okay, so does that answer your question?
Yeah, I did it with the inverse sine of theta, but how you
Oh, if you did inverse sine on your calculator, then I would say, okay, right here, I'd say t equals, what was the answer? 1 point something? 1.8 or 0.18? 0.183. And then I'll say, okay, what's AR? Because now it knows what t is, and so it can substitute it in, and what's a theta? Simple, right? Does that make sense? Use Mathematica for what you want it to be used for. Don't do it for everything. When I'm trying to make class notes and stuff, I try to make it all in Mathematica, so there's only one file you have to read. But when I do it for real, I don't do that. If the calculator's easy, if I can do it in my head, I'll do it in my head, right? Okay, you have a question?
How could you set up a boundary limit so you put theta from 0 to 2 pi?
I don't know. He's asking me how could I limit the solution. And I know you can. They'll do an inequality. So they'll say solve this with theta less than 2 pi greater than 0. And then it'll limit it for you. But the way I look at it is I could care less. I mean, for the kind of stuff I need. Now, if I was doing that 20 times a day, I'd figure out how to do it so that it would just do it automatically. But I'm going to do it once. I'll just pick it out myself. Okay, what else? Any questions about the exam? This is your last shot.
Are we gonna get like some sort of diagram of what you're asking for, or a picture?
If you can do the homework, you can do the test. Did all the homework have a figure?
Yeah.
All of them?
Yeah.
Not all of them. Not all of them, but some did. Okay. So if you can do the homework, you should be able to pass this test. Right? So if you haven't done the homework, I would worry.
how many problems are there?
There are 4 problems. I think you have lots of time based on my formula. Anything else? Okay, good luck. I'm gone at 9. I'll be back in the afternoon. He's got some mail over here that,
Professor, when will you be back?
You know-
when will you? I'm sorry. When will be when you leave UTEP after you come back?
about 5 o'clock.
Okay, thank you.
How long will you be here in your office?
I'm leaving right now for my doctor, and then I'll be back as soon as I get finished with him.
Okay, because I need to print the quizzes.
Okay.
Yeah, because there is almost 280 pages for 70.
Okay.
Yeah.
Okay. That's fine. You can use the printer in the main office. Would you like me to look at the numbers that you chose for Part B? Are you're confident you got them?
Okay, I will let you know.
Well, it's up to you. I mean,
Okay.
I appreciate confidence, but if you
After the
need,
class right now, after the class, I will go to your office.
okay,
Okay.
yeah, I'm not going to be there at my office. I'm leaving. I'm walking out right there and
Yeah.
grab my. Okay,
You will be here at after.
in the afternoon. Yeah. Do I do honors projects? I have. So can I think? When does that have to be turned in?
I think October 15th.
Oh, we got time then.
Yeah.
Okay. What I'd like to do is talk to you about because as far as I'm concerned, honors are you have to do something else too,
Yeah.
right? Okay. And so what I'll do is I'll sit down with you and find out what you have interest in doing, in learning, that I think I can help you with, or right?
Yeah.
And then I will, we'll reach an agreement and say, okay, that's what you'll do. Is that good?
Yeah, I can
Yeah.
stop by your office.
Sure.
Just, well, not today.
Not today, because it's a bad day,
Yeah.
because everybody's be panicked about the exam. So
Yeah.
maybe after the exam.